This is Debaprasad Mukhopadhyay, Assistant Professor of Mechanical Engineering, Sri Ramakrishna Institute of Science and Technology, bringing you this lecture. Today's topic is on Manufacturing Process 1, Group C, Welding, Part 1. This is as per second year third semester syllabus of Diploma in Mechanical Engineering. We will deal with gas welding and cutting in this particular lecture. Welding is a process of joining two similar or dissimilar materials. That is the basic definition of welding. It can be broadly classified as forge or pressure welding, fusion or non-pressure welding, and cold pressure welding. In our syllabus, we will deal with the fusion and non-pressure welding process. Forging will be dealt separately in another chapter. In pressure welding, heat is applied to the metals to be joined to bring it to plastic state, and pressure is applied to join them. Heat is generated in the following methods. This is actually briefly describing the forging process. Blacksmith's fire, that means heating in furnace or oven, passing electric current through the workpiece, or by friction process. In fusion welding, the welding that we are going to cover in this syllabus, heat is generated by either gas flame, by electric arc, or by chemical reaction. We will be dealing with the first two, that means the gas flame and the electric arc process only. Cold pressure welding is a recently developed process where two parts are subjected to extremely high pressure, which result in molecular fusion of the parts to be joined. This process is mainly used for joining non-ferrous materials like aluminium or copper. Now we will go into the actual process of heat generation by gas mixture. The gas mixture is either oxygen and acetylene or oxygen and LPG. Both are used for gas welding and gas cutting processes. Now, in case of a gas welding, the equipment needed for these processes are a welding torch. Welding torch will be of three types. It can be injector or just a low pressure welding torch. Then there is positive or equal pressure, sometimes called high pressure welding torch. This is more common type welding torch being used, and we will show it in figure 1. Now there is a tip at the welding torch which are called nozzles. These nozzles are made of copper and its alloys. The tip sizes are covered by the diameter of the opening. The diameter of the tip opening for welding depends upon the type of metal and the thickness to be welded. Now this is gas welding torch. Now you see the blue handle, that is where the operator or the welder is holding the torch. Now at the left hand side there are two pipe connections with two valves, rotary valves fitted on that. Now these two pipe connections will carry oxygen and the fuel gas, which is either LPG or acetylene. So the blue one is oxygen and the red one is acetylene or LPG. Now both these gases, they actually come to the mixing chamber and a proper mixing takes place there, and it comes to the end of the tip. Now when we burn the flame will be generated at the end of the tip. This is a gas cutting torch which we will be explaining when we will be dealing with gas cutting. So, the other parts of the gas welding system are pressure regulators. Why the pressure regulators are required? Because the gases are stored in cylinders at a very high pressure. One cannot use the gas at that high pressure. So, there are regulators to control the pressure of the gases when they are drawn from the cylinders. Now, these also ensure constant delivery pressure and gas volumetric rate irrespective of the pressure variation in the source, which are gas-filled cylinders. For plate thickness up to 25 mm, the regulator pressure of oxygen and acetylene varies from 0.15 to 0.70 kgf per centimeter square. Thickness above 25 mm, the pressure of gas will be 0.98 kgf per centimeter square. Other than pressure regulator, there will be gas hose and hose fittings. These hoses actually carry the gas from the cylinders to the torch. These are strong, durable, non-porous, light and flexible. The color of oxygen hose is black and that of acetylene is red. Then we have the gas cylinders, and the oxygen cylinders, they are stored at 12.5 to 14 meganewton per meter square, capacity 6.23 cubic meter and weight 66 kg when full. The acetylene cylinders are stored at 15 atmospheres and they are dissolved in acetone. Capacity is 7.6 cubic meter, weight is 86 kg. Then there will be goggles and gloves, because the welder, for the heat generated, he is putting his hands near the welding zone, so he will have to wear gloves, leather gloves mostly, and he will have to wear goggles also, so that the flame does not hurt his eyes. Then we have a spark lighter to ignite the gas, and then we have welding rods in gas welding. Welding rods are used to supply extra materials to the welding joint. Then we have fluxes. Oxide of metals generated during the welding produce poor quality welding and reduce strength of the weld joint. Fluxes are chemical compounds that forms a fusible slag with oxides of most metals at the welding temperature. This slag floats on top of the metal and do not interfere with the molten metal. That is how the oxidation of the red hot material is avoided. Now we will go into the types of gas flames. The reactions that take place in the gas flame is that the acetylene, which is C2H2, it combines with oxygen and generates carbon dioxide and hydrogen. This reaction takes place within the inner brilliant white core of the flame, which provides the heat and high temperature around 3000 degrees centigrade required for welding. In the second stage, the CO and H2 together with oxygen in the air form carbon dioxide and water. So this is 4CO plus 2H2 plus 3O2 gives you 4CO2 and 2H2O. This reaction takes place in the larger blue part of the flame, which surrounds the welding cone flame. The larger blue flame contributes only a penetrating preheating effect for the welding. It prevents oxidation of the molten metal. Now, the gas flame has got three characteristics. One is a neutral flame. This flame is obtained by equal volume of oxygen and acetylene, or LPG. When we supply equal volumes by controlling the valves that we have shown on the welding torch, we can actually control the volume of oxygen and acetylene. If it is equal, then we get a neutral flame. It has got one luminous core and outer envelope with bluish color. Most of the welding in steel, caster and copper aluminium is done with this flame. Then we have oxidizing flame, where the supply of oxygen is excess. That means supply of oxygen is more than acetylene. This flame is similar to neutral flame, only inner core is less luminous and shorter. It is used for welding for brass and bronze. Then we have reducing flame, or sometimes it is called carburizing flame. It is obtained with excess supply of acetylene. This flame has three zones, one inner cone, one intermediate cone and one outer cone. It is used to avoid oxidation and used for welding of alloy steel. It is used in the case of a molten metal, non-ferrous materials, hard facing materials. Now you can see here the shape of the flames. The first one gives you the carburizing flame, which has actually got three flames. One is acetylene feather, then the outside flame of white color, and then the light orange tinge at the edges. Then we have a neutral flame, which is other than the inner cone, white inner cone. This is actually colorless, and this is used for most of the welding process. And then third one is the oxidizing flame, where the color is bluish to orange due to extra supply of oxygen. The acetylene cone is there, and the outside is nearly colorless. The expert welders, they know these colors very well, and this has to be practically understood by controlling the two flow control valves to increase oxygen or increase acetylene and obtain these three colors of the flames. Here we have given some, a table where the different flames are used. Say for cast steel and steel plate, we use neutral flame. For high carbon steel, we use reducing flame. For wrought iron, we use oxidizing flame. For grey cast iron, we use oxidizing flame. And for cast iron pipe and chromium steel, we use neutral flame. Now here, some methods of welding has been shown. So this is not very important for us, but you can see that there are two methods. One is a rightward or backhand welding, and another is leftward or forehand welding. That means you move the torch from left to right or right to left for different welding purposes, and the characteristic of welding will vary along with this method. There is another method which is called vertical welding, but vertical welding in case of gas welding is best done by two operators for plates above 5 mm. That means two operators are welding from both sides of the plate simultaneously. Now, the most important process that we have come to is the gas cutting process. Because, to be frank, application of gas welding has reduced in industry to a great extent, and it has been taken over by the electric arc welding process. But gas cutting process is universally applicable in any fabrication industry. The gas cutting is done by the same mixture of oxyacetylene or LPG gas. The torch is different than gas welding torch. See figure 2. We'll come to the figure. The torch has an extra lever as shown in the figure, which when pressed, extra oxygen to the flame is supplied at higher pressure and oxidation of the already red hot parent metal takes place and the cutting occurs. So gas cutting process is basically cutting by oxidation. This process can't be applied to materials which does not get oxidized. For example, stainless steel, which can be cut by plasma or mechanical shearing, it cannot be cut by the gas cutting method. Here, the setup of gas welding is given. So far I have been discussing only, I was giving you a lecture on the apparatus and the arrangement. Here, you can physically see the arrangement. There is an acetylene cylinder here. There is an acetylene cylinder here and the oxygen cylinder, which is a little taller in height, and acetylene is the shorter in height. So you have the regulators there. As I said, there are two gauges. One gauge is reading the pressure inside the cylinder. Another gauge is the pressure at which the gas is being drawn from the cylinder. The torch is held here by the operator. There is a filler rod when you need extra material for welding, and the flame is burned here and the welding is done. These are the hoses who are actually carrying the gas from the regulators or from the cylinders to the gas welding torch. Here some temperatures are given. Propane is LPG. Propane and air flames has got a flame temperature of 1980 degrees centigrade. Propane and oxygen has got 20 to 53 degrees centigrade. hydrogen and oxygen is 2800 degrees centigrade, and acetylene and oxygen is 3500 degrees centigrade. As I told you at the beginning of the lecture, that it is around 3000 degrees centigrade. So oxyacetylene flame has got the highest temperature. So this is the setup for oxyacetylene welding. Now, for oxyacetylene welding or even for oxyacetylene cutting also, that same setup will be used. Now here we are showing actually a profile cutting machine where 4 welding torches are mounted on a machine which can move automatically in the X and Y directions. Why it is called profile cutting? Because you can see some of the small profiles which are being cut. Now suppose you want to cut a profile in large numbers, then actually the 4 torches that will be cutting simultaneously 4 pieces, and they are controlled by a numerical control center where the shape is actually digitally fed, and the machine repeats that continuously, one line after another, and large number of components, profile components, are cut. These machines can cut straight line also. If it moves in a straight line in one direction only, it will cut straight pieces also. But basically these machines are used for profile cutting. So we have come to the end of our lecture on gas welding and cutting. So gas welding is far less used than electric arc welding these days. But gas cutting is a totally universal process for cutting, particularly for mild steel in any fabrication shop. For stainless steel, because no oxidation takes place in stainless steel, you cannot use gas cutting. There you have to use plasma or biomechanical shear. So we come to the end of this lecture, and I hope that you have understood the gas welding and cutting process. In the next lecture, we will cover electric arc welding process. Thank you.